Hey everyone, today we'll be solving LeetCode 1043 partition array for maximum sum. It's a very important question and has been asked in Amazon, Adobe, and Facebook. Okay, let's have a look on the problem statement. In this problem, we are given an integer array ARR. Partition the array into subarrays of length at most k. Okay, after partitioning, each subarray has their value changed to become the maximum value of the subarray. Okay, it is saying that we will be given an array and we have to partition these array. Okay, let's say whatever partition you are making, let's say I have partition in this form, and the constraint we have to keep in mind that every partition should not exceed their length from this k. So here the first partition is having one element, two element, and one element each for rest of the partitions. So every partition is having a value or length less than k, so all partitions are valid. Now if I try to partition this array again, and if I partition the form like this, first three element in the first partition and then four element in the second partition. If I do this kind of partitioning, the first partition is having three elements and second partition are having four elements, which is more than k. So this is not a valid partition. And as per the problem statement, we have to partition this array such that every partition is having a length less than equal to k. So let's say I'm doing this 2 2 2. So all the elements are valid. And after partitioning, what is going to happen is that in this array, every element, let's say if one will be converted to the maximum value of its partition. So maximum value of this partition is 15. So one will be converted to 15 and 15 will also be converted to 15. 7 will be converted to maximum value of its partition, this partition, which is 9. 9 is already maximum, and from this partition maximum value is 5, so 2 will be converted to 5 and 5 is already 5. 10 is only one element in the partition, so 10 will remain the same. So sum of this partition is going to be 30 plus 18 plus 20, that is 68. 50 and 68. Okay, so 68 is the sum. 68 will be the answer if I partition in this form. This is a candidate to our answer, not the actual answer. So one possibility is something like this. And if I try to partition it again, let's say now we will use our mind to maximize this answer. So let's say if I partition something like this array, and here 10 I'm seeing the maximum value. If I partition like this, here I did 3 partition of this array, and every partition is having a length less than equal to k. 3 elements in one partition, one element in second partition, and 3 elements in second partition. So from the first partition, the values of all 3 elements will be changed to maximum value, which is 15. From the second partition, maximum value is 9 already. From the third partition, maximum value is 10. So all 3 values will be converted to 10. 10, 10 and 10. If I make sum of all of these values, it will come to 45 plus 9 plus 3, 10, 30. 75 plus 9, which is 84. In 84 is more than 68, which I previously calculated using these partitions. So now 84 is our candidate answer. We will consider 84 and we will be checking all the partition, and whatever like sum is going to be maximum, that is a valid partition, and we have to return this value, this 84. And I see that we cannot have any partition better than this, because here the maximum value is 15, maximum value is 10, and we cannot exceed partition more than 3. So 84 sum of this array after this conversion is going to be maximum. And also they are saying that return the largest sum of the given array after partitioning, and test cases are generated such that answer fits in 32-bit integer. Okay, we don't have to worry about the overflow and all. We'll just keep on calculating the sum. Okay, now the problem statement is clear to you. So as per the problem statement, we will be given an array and a value k, and we have to partition this array in such a way that the resultant array sum is maximized, and the resultant array will be formed from these elements. The maximum of this partition is 15 into 3, so sum from first partition is 15 into 3, from second partition it is 9, from third partition it is 10 into 3. So sum of these values are my array sum, and that array sum should be maximized. Now I hope that problem statement is clear to you, and we are also given constraints that array.length is already only 500, not more than that. Now we have to build our approach to solve this problem. Here what we have to do is, we are given a complete array, and from this array we have to find the maximum answer such that the every partition we can make is of size 3 maximum. Okay, so our array is going to start from this, and we have to solve this way. Let's say if I have to look up any small problem, let's say I consider only these four elements. So the like problem statement will become 9, 2, 5 and 10, but the partition size will remain the same. So here what we have to calculate is partition this array in such a way that every partition is not exceeding the length of 3, and we have to maximize the sum. So this problem statement is almost similar to this problem statement, just the input array is getting smaller. Okay, so we can say that this is a subproblem to our bigger problem. This is our subproblem, and this is our biggest problem that we have to solve this whole array. What do we understand using a subproblem? That we are having a subproblem, and if we have a look further, let's say we are solving this array only 5 and 10 with partition equal to 3. This is another subproblem, and at the least we have 10 as an array, and k is equal to 3. So we are getting subproblem in such a way that at some instant we are left with no array and k equal to 3. What is the maximum sum we can get? We can get 0 as a maximum sum. So here we are having a lot of subproblems, and we are solving these subproblems using recursion. From the bigger problem, if we have to solve a smaller problem, and we'll keep on doing the smaller problem, and then in the end we are getting a terminating case or edge case. So this is nothing but than a recursion. So we will be trying to solve this function using recursion. Okay, now let's try to understand how we will be solving it using recursion. Let's say I have some kind of helper function where it is getting a solution and some global variable. Let's say this is this array and this k value. So and what I'm passing to my solution is idx. Idx is what? The starting index of element from which I have to start solving. So here the indices are 0, 1, 2, 3, 4, 5, 6. And this is my bigger problem, that starting from 0 till the end, I'm considering this whole array with k equal to 3 value. Okay, so if I make a call to the solution function with index equal to 0, this is the biggest problem I'm having. And in the smaller case, how I'm going to break this problem? If we are starting with 0, we have three possibility. Either we consider 1 in our first partition, and we'll keep on doing the recursion with the rest of the array, or we have second possibility is considering first two element in our partition 1, where let's say partition 1 is, and the other possibility is that partition 1 is having 1 and 15. So we took 1 as a only single element in a partition 1, or two elements in the partition 1, or if we consider three element in the partition 1, it will look like this. Partition 1 is having 1 or 115 or 115.7. If I take 4 element in the partition 1, but here it will violate the k value, because k value is 3. So it means we can have maximum 3 element in our in any partition. So here in this case we are not going to consider p1 as a 115.79. The first scenario is that we are considering 1 as our first partition, and then we will make a recursion call that we believe that our solution function is will get answer to the rest of the array, and I'm just going to solve this only. And the other possibility is, if I try to solve this array 1 and 15, I will take help of my helper function. That my helper function that I started with index this, and after index plus 2 onwards you have to solve. I will just solve this much problem. Okay, and third possibility is that I'm considering 1, 15 and 7. and then asking my helper function to give me solution this index onwards, which is idx plus 3. If I am solving this, I will get answer from solution index plus 1. Solve it plus helper function will get you answer of index plus 2 onwards. Solve helper function will give you answer plus answer of index plus 3 onwards, and you have to solve this. Why we are solving is only 3 blocks? Because currently at every step we can have a partition of 3 size only. And here, so you have to solve only one partition, one possible partition, first partition, that is partition 1. And partition 1 itself can be of 3 type, because k value is 3. Now to now try to analyze our partitioning. If I partition from here, my answer array will going to have 1 here, and here this will be filled by recursion. Okay, if I'm partitioning against this value, our first partition is going to have 15 two times, and the rest of the thing will come from recursion helper function. Now if I partition from here, because maximum allowed partition size is 3, in that case my 15 will be considered 3 times, because every element of any partition 1 can be replaced with the maximum element of that partition. So 15 will be considered 3 times plus solution from my helper function. So my sum of the array will be 15 into 3 times. 15 into 3, 45 plus solution and further call. So I can make 3 calls here for k equal to 1, k equal to 2, k equal to 3. Sorry, you can say size equal to 1, 2, 3, or just ignore that. So if k equal to 1, I will be partitioning from here. If k equal to 2, I will be partitioning from here. And if k is equal to 3, that is size of the partition is 3, I'm going to partition from here. So we have 3 possibilities. If I'm and what I'm going to do is, from this array, index equal to 0, and from the answer of this function can have 3 possibilities. So maximum possibility from this I will be taking as my answer. So answer is equal to maximum of these 3, and these are my subproblems I'm going to call using recursion. So for the first one, the sum is equal to 1 plus solution, whatever the solution will get. Here in this case, 15 into 2, 30 plus helper function result. Here in this case, first partition will give me 45 plus answer from helper function. Okay. Now what we have done so far is we are done with our first partition and answer from my first partition. The maximum of these 3 value will serve my answer. So in this way, we are going to approach in the recursion form. And what is the terminating case of the recursion? Let's say after keep on doing partitioning, I'm getting an empty array, or you can say my index is going out of bound greater than equal to n. In that case, whatever value of k it is, the maximum sum we can get is 0. As we do not have any element, how do I get the sum? So this is going to be our terminating case. If index greater than equal to n, return 0. Okay. Now we have to consider one more aspect, which is whether we are getting these subproblem overlapped or not. Okay, let's say here we made call of solution of 1 because it was first index. Here I made call of solution of 3. Now from solution of 1, if I consider 3 elements, if I further consider 3 elements in this partition, let's say like this, 1, 2, 3, 4. So it will make further call to some value plus solution of 4, right? And from here, if I consider only one element, because at every step we are considering either one element, two element, or three element. So let's say from this function we are considering three element, or from this function we are considering only one element. So from solution 3 will further make call to solution 4, because I only consider one element. So here what we will do is we are doing our recursion in this form, coming here, solving solution 4, and then we are doing a load of thing, and after some time we are coming here and doing the like processing of solution 4 again. It means we are going to have overlapping subproblems. So these solution 4 and these solution 4 is getting processed multiple times. It means that my solution function against the value of index should be cached somewhere. That is, if I'm solving solution 4, I'm getting some result, and if I again trying to solve solution 4, I should get the result from cache, not directly processing it. If I do not process it from cache, so it will be n raised to power k. About the time complexity being exponential, what I'm going to do is I will be memorizing the solution. I hope now here it is clear to you that first of all I tried to solve it using recursion, and then we figured out that we are having overlapping subproblems and we need to do the memorization. We have to cache the answer. And what is the what should be our cached key? IDX value can be my key. And in the constraint we are given that index size, that array size is till 500. So if I take an array of 501, that is sufficient to store my answer. And once we have did the recursion with memorization, what is going to be our time complexity? So the time complexity will be become order of n into k after memorization. And what about the space complexity? Space complexity is nothing, just the array I'm using to store my like cache. That will be order of n. Space complexity is order of n. So this is the time and space complexity of approach. So here we concluded our question using recursion with memorization, that is top-down approach using DP. Now we can code this out. Let's try to tackle this problem using recursion with memorization. So first of all, let's write the recursion for that. Let me take a solution function where I will be just passing the index. And what should be the starting value of index? Index 0. And what we have to return is, I will just directly return the value of this solution function. Okay. Now what this code represent is that this solution helper function will give me answer of this array where value of k is as it is like given to us, and this solution will be the solution of array starting from 0 index. That is the biggest problem. And here I'm not going to pass these parameters in within the like function call. I'm keeping it globally. So integer n to store the length of the answer, integer array to store this array, integer k to store the k value. And here what I can do is this dot n is equal to array dot length. This dot a double r is equal to given array. This dot k is equal to k. Now my global variables are organized and I can use these variables in my global function. Now let's try to write our main function, the heart of the code, which is solution function, and it is going to return the integer. That is my answer to the biggest problem. Solution here integer index. What was my terminating case? That when there is no element left in the array. That is, if index is greater than equal to n, we can return 0. If index is greater than equal to n, that is no element left in the array, maximum sum of that array we can get is 0. Okay, that's clear to us. And now what I will do is I will try all the partition of k size from size 1 2 3. So let's say for that write a loop of k times I equal to 0, I less than k, I plus plus. Okay, now here I will try to use all the partition of k size, as well as I will have to check whether I plus idx is not exceeding the limit. It should be less than n. This is a corner case. Here what I have to do is first of all, I need to know what sum value the first partition is going to contribute. For that, I need to track the maximum of the current partition. That maximum of the current partition I will keep on calculating while doing the iteration, not every time. So let's say it maximum is equal to math dot minimum underscore value. Okay. Now maximum element of this partition is maximum equal to math dot maximum so far, and array of idx plus I. Okay. This partition is starting from idx and I is the increment in that partition. So first element of this partition is going to be idx plus 0, then idx plus 1, idx plus 2, and maximum I will be getting as I will be partition iterating through the partition from left to right. Okay. Now we this loop will be called 3 times as per our first example. In the first partition, let's say I'm partitioning over 1 and then getting answer from this solution. So I will also need to capture a variable result to store my result. Let's also keep it minimum value. Math dot minimum value. And what is the result I will get every time? Result is equal to, first of all, we have to maximize our result. Result, comma, the value we will write here. What value should we write? The sum from current partition length. Let's say currently we have captured this first two element. So how do we get sum of this partition only? The maximum value we have captured so far into the current partition size. What is current partition size? I plus 1. If I equal to 0, it means current partition size is 1. Plus the solution helper function will give me result of the rest of the array. Solution where I will be passing index plus I plus 1. Okay, now have a look on the example 1. If we consider this as a first partition, the helper function will get me result of this array. Index is 0, I is also 0 plus 1. Index plus I plus 1. If I consider this as a first partition, I will ask my helper function to get me answer of this subarray starting with index 1. Okay, in this way we have captured our result, and ultimately what we have to return is nothing, just a result. Now let's try to submit this problem. If okay, I'm running over sample test cases. Here I got some error. We should not put semicolon here. Running it again over sample test cases. Okay, so this is my recursion approach where it is going exponential. Every time it is going creating three more calls. If I submit the problem, it is definitely going to give me TLE. Let's try. Okay, I got TLE. So we have to memorize our solution, and in my solution function, I'm only passing one variable, which is index. So if it is not clear to you that what we have to memorize, just the variables among solution function we have to memorize. So we have only one variable, index. What can be the value of this index? This index value can be from 0 to this array length minus 1, 0 to n minus 1. That is the DP array we can use, can be of same size as array. Integer array DP. So DP array is equal to new integer of size n. So every value of index can be stored in this DP array. And before returning from this function, I'm going to store it against the index. My first call, my top-down recursion's first call, which is the biggest problem, is starting with index 0. So DP of 0 is going to give me the answer that we are directly returning from the solution. And after processing, we are storing our result. And before processing, we have to check whether we have already solved it or not. And also our elements are starting with 0. Okay, let's say if we have all the elements are 0, in that case we unnecessarily are going to make a further calls. So we will keep it wrapper class. integer so that I can check whether it is not null or not. DP of integer. If it is not clear to you, you can comment down below. I will try to explain you further. We will check if DP of IDX is not equal to null. It means we have cached this value. If this value is already cached, we can directly return it. Return DP of IDX. Else we will do the processing and then we will store our answer. DP of IDX equal to result. Okay. Now I think memorization is done. Submitting again whether we don't have any compilation error. Okay. Sample test cases are passed successfully. Submitting the problem. It got submitted successfully. Hope you understood the problem. Now we will have a look on the bottom-up approach. Hey everyone, this is our second approach where we'll be using bottom-up dynamic programming, or you can say tabulation method to solve our problem. So before that, you have to understand what is dynamic, what is bottom-up approach. In the top-down approach, we saw that we have a bigger problem that is a complete array we have to solve. And to solve this complete array, what we did is we want solution of this, and the solution of this we can get is solving some part of this array, and then we will further make a call to helper function that get me answer of this. From the bigger problem, we are moving to a small problem. Okay, for value of k equal to 3. But here in this case, in the bottom up approach, we have a tendency in a different manner. Like first of all, we will be solving a smaller problem first. That is, what is a smaller problem? So 1, 15, 7. This is a smaller problem to this problem. It means that if we have to solve this bigger problem, it means we have already solved all of its smaller problem. So first of all, you have to understand what is the smallest problem here. Smallest problem is that we have only one element in the array. Or you can say we don't have any element in the array. If we do not have any element in the array, the answer of that input is 0. If we do not have any element in the array and you have to partition in it in the size of k, and you have to give me the maximum value of the array sum we can get, that is 0. It's clear to us, visible to us. So after that, a small problem is this one, considering only one element. If we have to partition this array only, how do we partition? Considering one in the partition, and then if we are considering one in the partition, we have one plus rest of the input, which is a smaller problem, that is no element. From that we are getting 0, 0 sum. So if we have only one, we are getting sum as 1. Now let's say now our further bigger problem is 1 and 15. For 1, I have already stored that for a problem where the array is like this, we have a maximum answer is 1. Now we have an array where we have two elements, 1 and 15. So for the 15, we have to do the partition. How many ways you can do the partition? As per the value of k value is 3. It means we can have at most 3 elements in the partition. Let's say first of all I took only one element, that is only 15. In this way, what is the answer? 15 plus the answer of smaller problem. What is the smaller problem? Answer of this one array. But that smaller problem answer is already stored here. That is 1. So 15 plus 1, 16 is going to be the answer. Okay. And what are the other possibilities to do the partition? The second possibility to do the partition is partition from here. If I partition from here, what is going to be the value? I'm considering these two elements in that partition, 15 into 2, that is 30, because both the items will be converted to the maximum element of that partition. So 30 plus smaller problem. What is the smaller problem? We don't have any element in the array. That is 0 will get. So 30 is the answer if we have an array where we have two elements, 1 and 15. So till 15, answer would be 30, and this we can store in our DP array. I hope that is clear to you. Now let's say again we have one more element, 1, 15 and 7. 1, 15 and 7. So this is my bigger problem. If we are moving to the bigger problem, it means you have already solved a small problem. So for this one, I know the answer. 1 15. If that is the array, we know the answer. The maximum answer we can get is 30. Now for this 1 15 and 7, we have to know the answer. Maximum answer we can get. We have three possible ways to do the partition. If I partition from here, I want answer of this subproblem. If I partition from here, I want answer of this subproblem. If I partition from here, I want answer of this partition, this subproblem where I don't have any element. So let's say for the partition 1, the possible candidate to our answer is 7 plus answer so far is 30, which is 37. If I partition from here, that's it, this is second partition, 15 into 7, which is these two element in this current partition. It means both of our element will be replaced with the maximum one. The maximum one is 15. So 30 from this partition plus smaller problem, which is 1 only. So for this one, I know the answer from my DP array, which is 1. 30 plus 1, which is 31. So if the partition is this, that is partition 3, I have 1, 15 and 7 in one partition. So sum from this partition will be 15 3s are 45 plus sum from smaller problem, which is 0. So maximum value is 45. It means from 1 15, if I have this array, the maximum value I can get is 45. So 45 will be stored here. So in this way, we are going to use our approach to fill this table, and it is a 2D 1D array. 1D array of similar size we can have as an array, and we can fill this array in this manner. So if we keep on filling this array, so ultimately at the last index we are going to have answer of this complete array. That maximum sum we can get after making partition from this array is going to be stored at this position. Okay, I hope that is clear to you. Let's do one more iteration. 1 15 7 9. 1 15 7 9. So this is my array, and DP I have filled so far is 1 30 45 and 9 we have to fill. Okay, this is the current problem we have to solve. So we will see how many partition we can make. So first of all, I can make this partition. Let's say this, call it partition 1, or you can say this partition 2, where 7 and 9 is one partition, or this is partition 3, where 15 7 and 9 are in this partition. So as this is clear to you, let me just check whether store the answer of partition 3. Partition 3 is going to be 45 plus 1, that is 46. Okay, so for the partition 2, what is the value? The 30 from some sub problem plus from this partition 7 and 9, that is 16. 46. Now for the partition 1, for the partition 1, problem from answer from sub problem is 45, and from this partition itself it is 9. So 45 plus 9 is 64. So this is giving me the maximum value. It means the partition 1 is a very good partition, and the maximum value I can achieve so far is 64. Okay, so in this way you are going to fill the table. So first of all, taking a DP array of same size, and then for every index I will go j, for the j index k times in the left side. Firstly I'm considering one element, uh, like for every value of I am considering like. So how we are going to solve this problem? 1 15 7 9. For every element, for every value of I, it means from I we have to capture the value of this subarray. It means we will go to the left. So first of all, we will go to the left as per the value of k. If k equal to 3, we will consider one element starting with I, and then two elements starting with I, three elements starting with I in the left direction. That is, our j variable will go in the left side. And from if we are going out of bound, we can directly return 0. That is for the empty array, the result is 0. Okay, so for every index I will move my pointer j to the left side for to to check the possibility of k element in the in that partition. If I will keep one element in that partition, or I will keep two element in that partition, I will keep k element in that partition. In this way, I will capture the value of that partition and I will use my previously solved subproblem value. That is this memorization value. Okay, now let's try to write the code for this. In that case, we will get it will be more clear to us. And also, let's try to solve the time and space complexity for this. What is the time complexity? I am moving my j I value from 0 to n minus 1. So that is I is going n times n iteration of I, and for j can have at max k iterations. So the time complexity will be n into k. And what is the space complexity? Space complexity would be order of n, similar to the complexity we are getting in top-down approach. Let's start writing the bottom-up approach for this problem. Here, first of all, let's capture the size of this array, and then I will take a DP array. DP array of same size, new integer of n. And now I will keep my I pointer from starting element of this array till the last element of this array. That is from I equal to 0 to I less than n, I plus plus. Okay, that's clear to us. It means that we have to solve the problem ending at I index. So for I equal to 0, it means we are trying to solve the problem where we have only one element, I equal to 0 to 0. That is for 1. It means from starting from this I will move to the left side using my j pointer. So for that, let me just write another loop. Int I j equal to I and j minus. So what should be the value of j at the last time? At most to the left. We can move only k times to the left, so it should be j greater than I minus k. If the value of I equal to 4, so we will move the j pointer till I minus k. Okay, that is fine. And we will also check whether the j is not going out of bound. So for that, I will keep j greater than equal to 0. And here, as the j is decreasing, j minus minus. Okay, that is clear to you. And now while capturing the partition, we will keep track of the maximum value and the result as per our top down approach. Int maximum integer dot minimum value, and int result is equal to integer dot minimum value. So to capture the maximum value is equal to math dot maximum value, and the element at that j index. So array of j. Okay, maximum element is captured. Now let's capture the result. So result is equal to math dot maximum of result, comma, sum from that current partition. So current partition length is I minus j plus 1. Partition length is going from I to j, including both. So that's why plus 1. And we should multiply this with the maximum element of that partition plus dp of j minus I, because till j, that element is considered in the current element. Okay, now we also need to see that j minus 1 is not going out of bound. Okay, so for that, if the j is going out of bound, it means from that array our answer should be 0, because there is no element in it. So you can put a condition where j minus 1 is greater than equal to 0, or you can say j greater than 0. If j greater than 0, then we can use this, otherwise we are good to use 0. So this condition is important. It means that if I'm at 1, I have considered 1 from the remaining array, the dp of where the dp of j minus 1 I have to calculate, but it does not exist, I will get 0. Okay, now what I will do is I will be storing this result. So this is the maximum among all the partitions at ending at I index. So this result I can store in dp of I, that is equal to result. So maximum answer I can get till ith index is this result. So this is a small problem, and then we'll keep on solving bigger problem using small problems. Okay, I hope the problem is fine. Let's try to submit our sample test cases. Missing return statement. And what we have to return is, in the end, we can directly return dp of n minus 1. dp of n minus 1 is storing answer from for whole array. Okay, sample test cases are passed. Submitting the problem. It got submitted successfully. Hope you understood the problem. Thank you, guys.